Hello, we're doing checkpoint 5.10. Here they want us to find the double integral over the domain D of 2x plus 5y dA. And D is given here as a graph, and they want us to use two type 2 regions. If you remember, a type 2 region is a region that starts off with respect to x and then with respect to y. And it looks like it would make sense if we break up our region this way. And so we will have first the region up on top and then the region down in the bottom. Okay, so let's call this region D1, and let's call the one down below D2, and let's work on each of those regions separately. So the D1 region is going to be type 2, so we want to lay out our inequalities for x and or y, and it looks like I might need a little bit more room here, especially for the x limits. And remember, the trick is to draw a line parallel to the x-axis, or to the axis that you're integrating with respect to first. Now let's do this in a different color. Let's draw a line going through this, and we want to identify the x value of the function that we're going to get into. And notice this is a function, y as a function of x, so we really want to solve for x here in this case. So x is equal to, let's take the square root of both sides, and let's subtract 2, so the square root of y minus 2. Now usually when we take the square root we get plus and the minus, but the minus side is on this side, on the left side, so we're not going to be concerned about that. So our lower limit is a square root of y minus 2, and then we will be in there until we get out of the upper limit. And the upper, if you tilt your head sideways, or the function on the right, which is an x function already, is a function of y, so we just need to write down what that y is, and that's y minus 1/16 times y cubed. Okay, once we know that, the outer limits, the last limits that we deal with, are always going to be constants, and with respect to y, this is y is equal to 0 to y is equal to 4, so it's just going to go from 0 to 4. And here is our first set of limits. Now let's work on D2, and we will approach it the same way. It's a type 2 region, and we're going to integrate with respect to x first, and we will draw a line parallel to the x-axis going into the region and out of that region. So if we draw that line, we will enter through the region through a constant x is equal to -2 line, and we will exit that region through this same function again. So x is equal to -2, and that same function that we had before, y minus 1/16 times y cubed. Now our y limits, going from lesser to greater, are going to be constants. We're going to go from -4 to 0. Okay. All right. Next, we will put this into the integral, and our double integral. First of all, let's acknowledge that our double integral over d of this function 2x plus 5y dA will equal to the double integral over d1 of that same function plus the double integral over d2 of that same function. Okay, and we will set up the integral. Our first integral will be an integral of 2x plus 5y dA, and so this is a type 2 region, which means we're going to integrate with respect to x first, and our x limits go from the square root of y minus 2 to y minus 1/16 y cubed. That's your x limits, and then your y limits go from constant 0 to 4. And that's your first integral, and your second integral will be similar. Our lower limit, well, let's write down the integrand first. That's going to be 2x plus 5y. And again, dx dy. Our x limits go from -4 to that function, y minus 1/16 y cubed. And then our y limits go from, oops, I'm sorry, this is -2. And the -4 is for the y limits. -4 to 0. Okay. These integrals are fairly easy to do. We integrate with respect to x, and then we'll put in these values, and then we'll integrate with respect to y. So these are just a bunch of polynomials and power functions, which is not going to be that big of a deal. It's just going to be a little tedious. What I do want to do is recreate this graph on Desmos, and then we'll see a little bonus in Desmos. I have these graphs already drawn out, but clearly this is not showing the values or the regions that we want. But what's neat about Desmos is that the way we can express these things would actually be the way we would express regions. And so, for example, we can actually write it as if they were integrands, or those inequalities that I've been writing. So if we take a look at this first region, the domain D, it's going to go from an x value is going to go from root y minus 2 less than or equal to x less than or equal to that function. And then the y goes from 0 to 4. So literally, if we type that in, well, almost literally, except we're going to do a little something. But if we type the square root of y minus 2 less than or equal to x less than or equal to that other function, y minus 1/16 y cubed, we see that it goes kind of goes up there, and that's probably more than what we want. But if we tack on here in curly brackets our limits for the y value, so our limits for the y value goes from 0 less than or equal to y less than or equal to 4. And close that. Well, that didn't seem, oh, this should be y cubed, sorry. There you go. Now we see that we got this first part of our drawing. Now let's see if we can recreate the bottom part using the way we express the limits of integration. I believe this was a -2 less than or equal to y less than or equal to that same function. I'm just going to go ahead and copy and paste this same function. Oops, that didn't work out. Let me just type it in then. Y minus 1/16 y cubed. I'm sorry, those are x limits. So again, this covers a whole bunch of things, but if we again restrict your y values from -4 less than or equal to y less than or equal to 0, then we have that bottom part of our region. So we have just recreated the region here and using this. So that's one way to check to make sure you got the right region, is to go to your Desmos and type in the limits as you have them written, except your outer limits here would be in parentheses or would be in curly brackets that follows the first set of limits. Okay, now the bonus part. Well, the bonus part is that Desmos, I don't know if you knew it, but Desmos does integration. So int is your magic keywords for integration. And if we focus on the first one, the outer limits are going to go from 0 to 4. So I'm going to type the limits 0 to 4 for the y. And then not only does it do regular integration, it does double integration. And here the inner limits start from the square root of y minus 2 all the way up to y minus 1/16 times y cubed. And your integrand, I believe it was 2x plus 5y. Oops, that should be a plus, 2x plus 5y. And then we're going to integrate with respect to x first, and then with respect to y. And here is our decimal approximation for that limit. Okay, we can recreate the same thing to get our second integral. Our second integral, this time it goes from minus 4 to 0, and the lower limit is -2, and the upper limit stays the same, and here we get a negative value, it looks like. Alright, so if we basically add these two, we're going to get the sum of what we actually want. So let's put those there, and then we add them up. We're going to get approximately 20, maybe 12 point something. Well, I suppose we can ask Desmos to do that for S as well. So it'll be 60.876, and depending on how far you need to round off, minus and then a negative or plus, and then a negative 48.457. And I think that's good. If they want the actual raw value, you can pick that up as well, because like I mentioned, these integrals are fairly straightforward. There's nothing fancy, there's no special functions, there's no special substitutions, just a bunch of power functions. Okay, this is our checkpoint. I hope that helps.